So the goal of this video is to eventually find the general solution to this differential equation we see at the top here. But we're going to do this using some idea about knowing one solution and then using that solution to find the other. So the first thing we're going to do is just verify that y equals t to the negative 2 satisfies this dE. And this won't take too long because derivatives are actually straightforward enough. So the first derivative is negative 2t to the negative 3. And the second derivative is 6t to the negative 4. So we have t squared y double prime plus 5t times y prime plus 4y equals 0, at least we hope so. So let's multiply this all out. So we have 6t to the negative 2 minus 10t to the negative 2 plus 4t to the negative 2. And yes, that does end up being 0. So that is a solution. So now to find the second solution, because remember, a second order differential equation has two linearly independent solutions, we go to a little bit of theory. And that theory is, if we know that y1 is a solution to a differential equation of this form, then y2 is equal to some function u times y1, where u is equal to this integral. So the thing to keep in mind from the equation up at the top, and I'll be writing down that equation again. So remember, we had t squared y double prime plus 5t y prime plus 4y equals 0. Notice that the coefficient of the second derivative term is 1 for this particular formula. So the first thing we need to do is divide everything by t squared. So you have y double prime plus 5 over t y prime plus 4 over t squared y equals 0. So that means we can just plug all of the things that we know into this integral and onward we go. So we know what y1 is because that was given earlier. And we know what p of t is because that is the placeholder for y prime. So this is p of t, and y1 is t to the negative 2. So off we go. One thing I'm going to do is I'm going to find this first. So we have e to the integral of negative 5 over t dt, which is e to the negative 5 natural log t, which we know is e to the natural log of t to the negative 5, which is t to the negative 5. Okay, so that is that integral. So that means u is equal to the integral of 1 over t to the negative 2 squared times t to the negative 5 dt. This looks much more doable now. So we have integral of, well, that's going to be t to the 4th times t to the negative 5th, which is 1 over t. Oh, that's a nice integral. So that's going to be the natural log of t. So that tells us what to multiply by y1 to get the other part of the solution. So therefore, y2 is equal to u times y1, which is t squared t to the negative 2 natural log of t. Now, the one thing you're probably wondering is, why didn't I use a plus c to find that integral? Well, let's just take a quick exploration on that. If I had added a plus c here, that means we would have had t to the negative 2 natural log of t plus ct to the negative 2, which is fine in itself, but remember that that was already part of the general solution, so we don't need that to show up again. And it turns out just letting that integration constant, fall by the wayside is okay. So we're only focused on the part that we get before the plus c. So then as far as a general solution goes, we know that a general solution is y equals c1 times the first y plus c2 times the second y. So we have c1 t to the negative 2 plus c2 t to the negative 2 natural log t. And that is our general solution. So for any value of c1 and c2, that will satisfy the original differential equation. Later on, we're going to look at another way to solve this particular kind of differential equation, but for now, at least we know that if we happen to know one solution, we can always find the other. So thanks for watching, and of course, as always, watch out for more videos.